So today we're going to look at section 7.4, the first part of it. We are going to use properties of logs to expand and condense expressions. And our focus today will be on the condensing part. It says each property of exponents equates to a property of logs. So in the past, when we've looked at exponential expressions like this, x to the third times x to the fourth, we know we can add the powers. And that's going to equate to our log expression, or our log property, that says if we are taking the log base b of a product, we simply add the individual logs. So the log base b of m times n is equivalent to the log base b of m plus the log base b of n. So remember that the answer to a log expression is really a power. So this is really just saying we add the powers. Okay, then we have a quotient property that says we are subtracting the powers. This would turn into 8 minus 3, or x to the fifth. We subtract the exponents. So that equates to our quotient rule for logs. It says the log base b of a quotient, a fraction. We're dividing m by n. We can simply subtract the log base b of m minus the log base b of n. And then the last one says if we have a power to a power, we multiply those powers. So this becomes x to the 10th. And that equates to our bottom one here, the power property, that says we can take that exponent, move it out front, and multiply it to the log of m. So we are multiplying the power n and log base b of m, which is a power as well. So we're multiplying the powers. All right, so we're going to use these properties to help us expand and condense log statements. All right, so what I want you to remember is that when we are looking at multiplying, we are going to expand it into addition. If we see addition of two logs, we're going to condense it back into multiplying of them. For division, that equates to subtraction. So if we see a subtraction, a log minus a log, we can condense that back into a division problem. And the last one, if we see a power, we can multiply it. So any powers have been moved out front, we can put them back, condense it back, and know that it's a power. All right, so today, like I said, we're going to focus on condensing logs. This means any coefficients are needing to be put back as powers. Okay? And then any adding or subtracting of logs is going to condense back into multiplying or dividing. When you condense, you should have a single logarithm at the end. So when you look at these examples, you'll see several different logs. When we condense, it's back down to 1. And you always have to have the same base. So here we have log base 2 of 5 plus log base 2 of 3x. Because we are adding here, we're going to condense that back into multiplication. So we'd say the log base 2 of 5 times 3x. Okay, addition condenses back to multiplication. So this just becomes the log base 2 of 15x. Okay, second one. We have a subtraction sign. Subtraction is going to condense back into a quotient. So we have a subtraction of two logs. We have to put it back as division. So log base 3, we have a 10y squared, and we're dividing it by the 5y. So again, notice we have a single log when we condense it. We're taking the 10y squared divided by 5y. We can clean this up a little bit. It is log base 3. The 10 divided by 5 would be 2, and the y squared divided by y would just be a 1y. So we get log base 3 of 2y. Our third example, you'll see a number out front of the log that's being multiplied to it. That is our power property. That 2 used to be a power of this. So we're going to put it back as a power when we condense. So the log of 7x to the second power, we can distribute that power and it becomes the log of 49x squared. Okay. In the next one, you'll see that we have a couple different properties being used here. I see a coefficient in front of that log piece. That's going to have to go back as a power. And I also see a subtraction sign, which is going to condense back into division. So let's start out putting the power back. So log base 5 of 9 minus, the 3 goes back, we get log base 5 of 2 cubed. 2 cubed is just 8. So this is log base 5 of 9 minus log base 5 of 8. And then we can condense the subtraction, and it becomes log base 5 of 9 divided by 8. All right, our next example, we have two coefficients. They're both going to go back as powers. So this would be log base 2 of x to the 6th plus log base 2 of y to the 5th. And then addition of two logs condenses down into multiplication. So log base 2 of x to the 6th times y to the 5th. All right. Our last example on this page here, notice that the 1/4 is in front of everything. So we're going to condense all of this stuff inside first. So we have 1/4 times, and we see a plus here. We're adding two logs together, which means the AB is going to get multiplied to the C. We're going to multiply those two pieces together. This becomes the log base 7 of AB times C. Now, the 1/4 applies to all of the ABC pieces. And a 1/4, when we put it back as a power, remember a fraction power is really a root. So we could write this as log base 7 of the 4th root of ABC. All right, sometimes condensing logs into a single log can help us evaluate it. Remember from section 7.3a, when we're evaluating, we're going to set it equal to x and we're going to rewrite it in exponential form. So what we mean by that is, let's pretend there's an x over here. We're trying to figure out what this equates to. I'm going to condense it because it's a log minus a log. So that condenses down into division. And 32 divided by 2 is just 16. So we have log base 4 of 16 equals something. And now we can do that loop. We can start with our base to our unknown power should get us 16. So 4 to what power gets us 16? Well, all we have to do to a 4 to turn it into a 16 is to square it. So our power would have to be a 2. For this next one, I do have a coefficient here that has to go back as a power. So let's start out with log base 7 of 1 minus log base 7 of 7 squared. 7 squared is 49. So log base 7 of 1 minus log base 7 of 49. And then condensing a subtraction goes back into division. So we get 1 divided by 49. All right, so let's set this equal to x. And we have 7 to some power should get us 1/49. So what do we have to do to a 7 to turn it into a 49? We would square it. But to turn it into 1/49, that means we need to square it and we need to flip it over, take its reciprocal. So to get it to square, we need a 2. To flip it, we need it to be a -2. So my x value here would be -2. All right, our next one, again, it's a subtraction. I don't see any numbers in front of those logs, so I don't have any powers to put back. I'm simply going to condense subtraction into division, so 2 divided by 16. We're trying to figure out what that is equal to. 2/16 we can reduce down to 1/8. So now if we do our little loop, our base of 1/2 is being raised to some power to turn it into 1/8. So what do we have to do to a 2 to have it become an 8? The 1 to any power is still going to be a 1, so the numerator is fine. But what do we do to a 2 to turn it into an 8? We would have to cube it. So our power would have to be a 3. 1/2 to the 3rd power becomes 1/8. And for the last example here, we have addition. That means we're going to condense it down into multiplication. So log base 36 of 2 times 3. 2 times 3 is 6. So log base 36 of 6 equals something. Do our little loop. So 36 to some power should get us a 6. Well, what do we have to do to a 36 to turn it into a 6? Using a power, we'd have to square root it, actually. The square root of 36 would get us a 6. So the power that would be equivalent to a square root would be a 1/2. All right, so today you are just focusing on using those 3 properties of logs to condense. So again, if we have a log plus a log, we're going to condense that down into the log of A times B. If we have the log of A minus the log of B, we're going to condense that down into log of A divided by B. And if there's a number in front of your log, it goes back as a power. So log of A to whatever that number was. All right, so use those 3 properties and condense your log expressions.